Okay, I'm just going to draw the diagram here, guys, so you can see if you did yours correctly. Okay, our first vector is south of west, so I'm going to draw a line here that's due west, and then I'm going to go 18 degrees south of it for 200 meters. Here's y, okay, here's x, 18 degrees south of west for 200 meters. And then I'm going to have a line that goes north of west, okay, at a steeper angle for 165 meters. That's a little misleading. That side's definitely not that long, but you get the idea. Okay, here's y, here's x. Okay, that'll be my angle there, and this will be my overall displacement here. Okay, so your diagram should look like that. It's a little exaggerated, I think, on the y, but you get the idea. Scale's important. I exaggerated the important part of the scale. Okay, let's walk through this one here, guys. Okay, and guys, I purposefully made this one so that it would be a tricky diagram. That's the thing that's challenging us right now, so I need to challenge you on your ability to draw these diagrams correctly. Okay, so for our red triangle, okay, x is our adjacent side to the 18-degree angle, so it'll be the cos of 18 times 200 meters. Y will be the sine of 18 times 200 meters. Okay, so I'll get those two numbers. All right, so we're looking at 190.211 meters, and that is going to be west. Okay, and then for the other one here, I've got sine of 18 times 200 meters is 61.803 meters, and that is south. All right, then I have to do the same thing for the green triangle. X is adjacent to the 25.5-degree angle, so I'll have the cos of 25.5 times 165 meters. Okay, y is going to be the sine of 25.5 times 165 meters because it's the opposite side. All right, so cos 25.5 times 165. All right, so that's 148.927 meters, also west. Okay, and then for y, we have the sine of 25.5 times 165, okay, which gives us 71.034. Okay, so 71.034 meters, and that one's going north. Okay, so whether you're using this combined tail to head method or whether you're using the separate triangle method, these numbers are the same for you. Okay, if you're using the separate triangle method, okay, then at this point you are having to construct or find your x and y's so you can construct your resultants triangle, okay, which I can show you here in just a second, right? But for right now, let's find our resultants. That's the blue x and blue y. Both of our x components are west, 190 and 148. So we're just going to add those together. So we'll take our 190 with all the decimals plus our 148 with all the decimals and get our final x component. So 190.2113033 plus our 148.9265719. All right, so we've got our 339.138 meters west. Okay, so if I was building my resultant triangle using the separate triangle method, I could draw one of the two x components, or one of the components, sorry, the x one. Right, so I would have that, and it would be 339.138 meters. Okay. And then I got to find my y, resultant y components. One of them is south, and it's the smaller of the two. All right, so I'm going to take the 71.034 north and subtract the 61.803, okay, since it was south, and I'll get my resultant y. So okay, so I'm getting 9.23. I did it backwards, but that's fine. 9.231 meters. And that's going to be north. So now I can draw that on here. Obviously, it's not going to be that big, but okay, just so I can show it. If I draw this to scale, it's like a little tiny thing right here that you wouldn't even see. Right, so I'm exaggerating the scale a little bit here. 9.231 meters. Okay, and that one's north. Well, there's my resultance triangle. Okay, which looks pretty much like the one I drew up here. I just drew the opposite one, right? It's like this. This is the same triangle, right? It's still pointing the same way. All right, now that I have those, now I can find what my overall displacement is using Pythagorean theorem. Okay, so we have our 339 squared plus our 9 squared, obviously with all the decimals. But I'm squaring it, won't matter. Yeah, I thought of that, but yeah, you're right. And it's okay, because I make mistakes, and you got to keep an eye on me and make sure I'm not screwing things up real bad. Okay, so we changed, it's not going to change very much because obviously it's a very thin triangle. Okay, so 339.26. 0.26 meters is our overall displacement that I got to find the angle, right? I'll use this triangle here just because I've got it close, right? So theta will be 10 to the minus 1 of the opposite side, which is our 9.231, okay, over our 339, 339, blah, blah, blah. Okay, so we'll get our angle here. Oh, 2309. Okay, so it's a pretty thin triangle. The angle is 1.56 degrees. And for that triangle, that's north of west. If you drew it the other way, it's the complementary angle. Okay, so that means our final answer, we only have two significant figures, is 3.4 times 10 to the 2 meters at 1.6 degrees north of west, or at 88 degrees west of north. Okay, I know one has a decimal, the other doesn't, but they both have two significant figures, right? That's the way we have to write them. Okay, but that would be our final answer there. Okay. No, go ahead. Question. Okay. Oh, because it didn't matter, right? I was trying to demonstrate the separate triangle method by using this triangle, okay, that I constructed using the separate triangle method. But in the end, this angle here is the 88 degrees, right? It's just the flipped version. They both have the same x and y values. It's just whether I use it as opposite or adjacent is all that changes. Yeah. Okay. Other questions on that one? Okay, so obviously, guys, it's pretty important that we're doing these right. It's pretty important that we're getting better at doing them quickly. Okay, that's the big thing, is getting not only good at doing them, but better at doing them faster. So here's what we got to do today. Okay, I know there's a few of you that are really struggling with the tail to head drawing. Okay, if that's what's giving you trouble, especially when we get a question like this where it's tricky, then you really should be using the separate triangle method. Okay, remember, the math is no different. Okay, all the steps are the same except this diagram. So you're not really changing a lot of what you do, but it's hopefully going to make it easier for you to solve the problem by not having the diagram confuse you. Okay, so treat the triangles separately. Okay, come up with your resultant after the fact, as opposed to seeing something that may not be right because you drew the diagram wrong. Okay, scale doesn't matter if you're using the separate triangle method. All that matters is that you draw the triangle in the right direction. Okay. All right, so I want you to continue working on those ones from before. Okay, I'm going to interrupt occasionally with something different. Okay, but that's what we're going to be working on, because tomorrow we'll have a quiz on vectors, and then we're going to do the assignment on vectors, and that'll be it. We'll start projectile motion on Wednesday. Okay, projectile motion is the last thing. So on Friday, I will post a unit exam review package in Google Classroom. The idea being you find some time on the weekend to look it over. Okay, Monday, I will do a formal unit exam review, okay, for you, and then we'll go from there. Okay, everybody follow me on that. Okay, let's have a look at 15 here now, guys. So we got 3 vectors in number 15, right? Doesn't really change what we do, we just have to do it 3 times instead of 2. Okay, so we have a football game where a player runs 10.5 meters at 25 degrees south of west. So, okay, I start out with a reference line that is west. I go 25 degrees south of that, something like that. Okay, 25 degrees. This is going to be 10.5 meters. Okay, this will be y, this will be x. So that's my first vector. Then the second vector is 15 meters at 20 degrees west of south. Okay, so it's longer, right? And it's 20 degrees west of south, so that would be this way. Right, so here's y, here's x, there's our 20-degree angle, and this is 15 meters long. Probably not the best scale, but okay. And then we go 8 meters south, right? That means our resultant goes like so. And you could draw that triangle either way, doesn't really matter. Okay, and there's x, and there's y. So that's what our diagram should look like. Okay, now we got to same thing we always have to do. We got to find all our x's and all our y's. So red x is the adjacent side to the 25-degree angle. So cos of 25 times 10.5 will give me x. And red y will be the sine of 25 times 10.5. Okay, so we got 9.516. And that's going to be meters, and that is west. Okay, and then sine of 25 times 10.5 is 4.437 meters south. Then we have the blue triangle. Okay, so we have x is the opposite side on that one, so the sine of 20 times 15 meters. Y is the adjacent side, cos of 20 times 15 meters. Okay, so 5.13 meters, and that is west. Okay, and then we have cos of 20 times 15 is 14.095 meters, and that one is south. And then our third vector, okay, well, x is 0 meters on the green vector, and y is 8 meters south on that one. All right, so that means if I want to find my resultants, x and y, I've got a lot of adding to do. Luckily, it's all adding. I don't have anything that backtracks. All the vectors go west, all the vectors go south. Okay, so there's no negatives or anything like that to throw me off. All right, so my resultant's x is going to be 9.516 plus 5.13. Okay, and that'll give me the resultant x, and the resultant y is going to be 4.437 plus 14, sorry, 14.095 plus 8. Okay, so we got 9.516, 23 plus 5.13, 5. Okay, so we got 14.647 meters, okay, for that one, and it's west. And then we got all of our souths to add together. So we got 4.437, is that right? And I don't have all the decimals. I'm gonna do what I shouldn't do, okay, and just leave it at that. 14.09538931 plus 8. All right, so we got 26.532 meters south. Okay, so now I can find my overall displacement using those two sides in Pythagorean theorem. If I had done this using separate triangles, I would simply build that triangle right now. Okay, so I would look at those two numbers and I would say, okay, I've got a 26 meter south line, and then I've got a 14 meter west line, and boom, there's my resultant, and I would go from there. It's the same triangle, I just built it separately, okay, in separate triangle method than I did here. Okay, so to get my overall displacement, it's going to be our 14.6 squared plus our 26.5 squared, obviously with all the decimals, even though I've already screwed that part of it up. Okay, so like I say, I've already screwed that up, so I'm not carrying them all. You will. Okay, it gives me 30.3 meters. And then to find the angle, okay, the way I drew that triangle, x is my opposite side, y is my adjacent side. So I'm going to go tan to the minus 1 of the 14.6 over the 26. Okay, so we're looking at 29 degrees. Okay, and for me, that 29 degrees is going to be west of south, but you could have had the complementary angle of 61 degrees south of west if you had that. Okay, so two significant figures here, I think, is all we have, right? Yeah, 2. The 15 meters only has 2. Okay, so we're looking at 30 meters at 29 degrees west of south, or at 61 degrees south of west. Okay. All right. Now, I didn't do as much explaining on that one. How long did it take me? Less than 7 minutes. My timer was at 11 minutes something when I started, and it's at 18 something now. Okay, so it took me like 7-ish minutes. All right, so when we start getting fast, okay, and that one had 3 vectors. I'm a superstar. I don't expect you to be there yet. Just kidding. Okay, so that's what we're kind of headed towards on that, guys, is being able to do it that quickly. Okay. All right. Now, hopefully you guys are moving on to number 16, okay, with Indiana Jones and carrying the golden idol. If you have not seen Raiders of the Lost Ark, crawl out from under the rock you have been living under. Watch it on Netflix. I'm sure it's on Netflix. It's awesome. It's like possibly one of the greatest opening scenes of all time. Okay, you have to see it. We're actually going to do a question in that from that movie in the next unit. It has to do with the big rock that chases them through the tunnel. Okay? It's an inclined plane question, so I come back to that one all the time. All right, questions on this one, or any questions? Oh, for part B? So if it took 35 seconds, so all I do is take this displacement and I divide it by 15 seconds, or 35 seconds. Hmm? Oh, but it says, oh, sorry, it's speed. It's not displacement, it's not velocity. So I just add all the distances together, right? So I add the what do we got here? Sorry, I lost my place. So 10.5 plus 15 plus 8 divided by 35. Yeah, it's a trick just to catch and see, and it caught me too. Okay, to catch and see if, oh, right, speed scalar. We're doing all this vector stuff, but once in a while I throw a scalar thing in there just to make sure we're all awake, which we weren't. Okay.